Good evening and welcome to lecture 8 since we've been to online only courses. So I'm recording this at 10:30 at night almost, actually 10:37 at night. I wanted to start with some video. Again, I think this is important that you see people, you understand that we're still functioning. For this pandemic, it feels like, at least for me, it feels like I'm really disconnected with you. When I lecture, I look for body language, I look for facial expressions to try and guide me on whether I should slow down or speed up, whether I should ask questions. And so this form of lecturing, asynchronous, really mucks with my teaching vibe. And so I'm finding it kind of difficult. I'm sure you're finding it difficult to learn this way as well. And you have an open invitation from me to email me, contact me, do whatever. If something that I'm doing in these lectures is not working for you, or something is working for you and you'd like more of, I have to take a shotgun approach, which basically means I've got to try to lecture in a way that everybody will get, or most people will get. And if you're struggling, let me know. I am working on grades. I'm trying to get as much material graded as possible, as many of the programming assignments graded as possible. I posted the test 2 scores to Moodle in the gradebook on Moodle, and I'm about to start posting programming assignment grades. The midterm grades are due tomorrow, I believe, at 5 o'clock. Let me check that. Excuse me, and make sure. So midterm. Oh, goodness. From the registrar. So I'm just searching through my email here. Major changes, graduation, semester important dates. Crap. I don't have the email from the registrar on when midterm grades are due. Well, actually, what I'm worried about is what time. I thought it was 5 o'clock. So now I'm off looking through deleted email, which I have a lot of deleted email. Holy moly, I've got a full page of email just from today and 2 pages of email just from today in my trash. Payroll. In trash, midterm. Here we go. Yeah, it's through the day tomorrow. So I will be getting as much as I can graded before 5 o'clock tomorrow. Okay. Sorry about that. But I figured it was important to look that up, just so you know that by 5 o'clock tomorrow, which means they'll run midterm grades and you'll probably have them viewable, any that are posted tomorrow by Friday morning. And so you'll be able to look at those. Now, onto our lecture. So I'm going to drop the video and switch to just shared. And so let's share our PowerPoint slides on today's lecture. And so I'm going to start with some code. You know, these are some code patterns that work for these linear data structures. And so we're going to use these patterns for the rest of this term. And quite frankly, if you end up with a career in any kind of software design, you will use these patterns basically forever. I learned these patterns 38 years ago, and I still use them today. I use them regularly in code that I write for myself, research code, and code that I write for classes and that I teach. Now, these are what we call code idioms. There's something we've had to develop, like print stack, for our last program, but we really haven't thought of that or talked about that as being a pattern. So bear in mind, these use a pointer to the start of the structure. Normally we call that head. And we don't want to change head. When we're doing these patterns, usually we're leaving head alone, and we're using a temporary pointer or a couple of temporary pointers to do the work that we need to do. And so here's a simple code idiom that walks all the way down a linked data structure. So this will start at the front or the top or the head, whatever you call it, and it goes all the way to the end. And so the code idiom, assuming that the pointers and variables are properly defined, the code idiom is pretty darn simple. Temp equals head. While temp does not equal null, you do your work that you have to do at the current node, like printing the current node or whatever, and then temp equals temp arrow next, and off it goes. Pretty darn simple. If head is null, that is, there isn't any dynamically allocated data, there are no nodes in the structure is empty, then this while loop won't run at all, and it'll do what we need it to. Very similar pattern for if we're searching for a value. So we have some distinctive value that we're looking for in the data structure. We're going to have that value stored in a application data class, and we're going to name that target. So we're just searching for target, okay? And this assumes that the relational operators, that is less than, greater than, less than or equal to, greater than or equal to, and not equal to, are overloaded for our app data. And so again, very similar, temp equals head, while temp does not equal null, and temp arrow data does not equal target. Now, this is relying on a thing in C++ called loop short circuit, or not loop short circuiting, sorry, Boolean expression short circuiting. So if temp is equal to null, that first term, the first operand in the AND Boolean operator is false, and it will not evaluate the second operand of the AND Boolean operator. So temp arrow data not equaling target never gets evaluated, and that means that the temp arrow data, if temp was null, would produce a seg fault, but that's not going to get evaluated so it doesn't produce the seg fault. So this is relying on short circuiting in the Boolean expression. As soon as we get that false, we don't evaluate the rest because we know that the false and anything else is still false. If it's not false, that is temp does not equal null and temp arrow data does not equal target, then we just walk down the list or the data structure. So temp equals temp arrow next. We'll either get to the end of the data structure, which is temp equals null, or we'll hit a node whose application data is the target that we're looking for. That is temp arrow data equals target. So equals equals, okay? And then this last one, this last pattern that I'm going to show you for these linear data structures is something that I call shadowing. So we're going to shadow the temp pointer, and this this gets done for insertion and deletion in linked lists. And sometimes we do this for queues. Rarely do we ever use this for stacks, okay? And so this uses two pointers. I'm going to call those pointers temp and trail. That is, temp's the pointer I'm walking down the list and trail is right behind it. Trail is therefore always one node behind temp in the data structure. And so when temp is pointing to head, that is the first node. Think about it, head points to the first node in the structure. Trail is going to be pointing at nothing because there is no node before head. And so therefore trail has to start at null. So we initialize temp to head, trail to null, okay? And then while temp does not equal null, and in this case, I'm just going to pretend like we're looking for a place to insert or delete in a linked list. So, and temp arrow data is less than or equal to target. If I were looking for target to delete, then I would say just less than. If I was looking for the place to insert target, then I use less than or equal to. And so that's a subtle off by one error there in walking down the list. And so as long as temp is not null, and as long as the data that's in that node that temp points to is less than or equal to the target, then we move the trail pointer to temp. So temp and the trail pointer are pointing at the same node, the current node. And then we move temp one deeper or one along the list, basically to the next node. And so trail is always one node behind, okay? So those code idioms are going to crop up over and over in these last three programming assignments. And we'll see those idioms in other classes as well, other courses, I should say, other courses as well. 201, 342, potentially. And quite frankly, you'll see them in code that you write for yourself or for your employer. Now, let's return to our example code that we were writing the other day. And this is a particular type of thing that we can do in C++ and object-oriented programming. C++ allows us to define our own operator functions for operators that are in the language. So things like plus, minus, the assignment operator, multiply, divide, stream insertion, stream extraction, The relational operators like equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to, all of those operators can be overloaded. And the reason we do that, or the reason that that exists, is because we're creating our own types. So as we're creating a data type, a new data type, we're going to need a lot of these operators to be overloaded. And so we're going to look at overloading some stuff today. In particular, the assignment operator and the stream insertion operator. Those are probably, at this stage, the most valuable. When we get to linked lists, like in the code I just showed you, I said, assuming the relational operators are overloaded. When we get to linked lists and keeping things in ordered lists, we're going to want those relational operators overloaded as well. So, the assignment operator overload. Basically, this is the same code as the copy constructor. You are deciding how the data is going to move from one object to another. In this case, it's going to move from the right-hand side of the assignment operator to the left-hand side of the assignment operator. So this is, you know, like app data. You've got, let's say, temp data equals head arrow data, for instance. That equals operation is going to do exactly the same thing as the copy constructor did. The use of const in these is baffling. You know, I can never keep track of where the consts must go and where they must not and where they can go. And quite frankly, I can't remember the details. So I use a book, a textbook, to look up exactly what the syntax is and how to do this. Now, our textbook doesn't do a good job of the assignment operator overload and describing it, so I don't use our textbook. I use a different book. So the syntax is pretty straightforward-ish, almost. It is const, and then the class name, and then the ref symbol, the ampersand, the keyword operator, the actual operator, which in this case is the assignment operator, the single equals sign, and then it takes a single parameter, which is a const itself, and the class name, again, the reference operator, and then something we'll call the right-hand side, okay? We'll need to use this in code for the operator overload. Excuse me, we'll need to use this. Oh my goodness, I should have highlighted that. We'll need to use this in code for the operator overload. So this is actually the name of the current object in which the member function, the assignment operator function, is running. So it's basically saying me. When the code's running me, the object that I am gets referred to as this. So let's go over to the example code. So I'm going to drop the share for the PowerPoint slides, and I'm going to start the share over here, okay? So we're going to dump this into app data. So right up here in appdata.h, I'm going to put that right after the copy constructor. And this is where the prototype goes in. So the prototype is a const, sensor, ampersand operator equals, open up the parameter list. Inside the parameter list, that's going to be a const sensor ampersand and right hand side. Okay. So that's our operator overload prototype. What this is saying is that, so let me escape out of here. What this is saying is the operator equal sign, okay? On the right-hand side of that equals, remember we talked about the difference between left-hand side and right-hand side? So on the right-hand side of that, you're going to refer to that right-hand side as right-hand side. And it is of type sensor. It's actually a reference to a sensor. This is consistent with the way the equals operator works for like floats. The thing on the right-hand side has to produce a floating point value. And then it gets moved over to the left-hand side. And that left-hand side is actually represented right here. And that is const reference to the left-hand side. So again, it's a reference. That means that we can change its value, but we can't change where it is in memory because of the const right there. So the const says you can't change this. The sensor ref says you can't change the location in memory of this, but you can change the contents at that memory location, okay? So now, with that prototyped, we're going to go over to the implementation of app data. So in this case, sensor. And I'm just going to copy the copy constructor, okay? So I'm looking right here. It's, how many lines of code is this? So I'm going to copy that. So yank 13J. And then dump that in, okay? So we still need, you know, the scoping, actually, we do need the scoping operator, but it's in a weird place. So you have the const, and then you have sensor ref, okay? And then you have the scoping operator. And the scoping operator then works on operator equals, okay? And now, because it's not a copy constructor, we're not going to refer to original, we're going to refer to right-hand side, okay? So here, all of this code pretty much is going to be the same. But in this case, we have to return a reference to a sensor. And so instead of returning nothing like we did in the copy constructor, we're actually going to return a star this, okay? Star this is just simply that reference, that memory address of the current object. What this buys for us is the ability to chain the assignment operator. So this isn't code that's going in this function. I'm just going to write a little bit of code to show you what a chain of an assignment operator is. It's something like A equals B equals 42, okay? So this takes the value 42, assigns it to B, and then returns that value as the result of the assignment operator And so the 42 then gets passed along to A as well. So at the end of this, both A and B would be would hold the value 42. That's permissible in C++ and in C. And so if we want our assignment operator to work correctly, we need to return a reference to the current object. And that's what this return this does down here. Our textbook does not return this reference when it shows assignment operator overloading, at least the first time. And so that's a change from what our textbook shows you. If I've done this all correctly, this should compile. I thought there was a compilation in here someplace. Evidently, I was wrong. Really? Yep, I have not executed a compilation in here in a long time. Okay. So I'm going to compile this. What do I have in here? Oh, I'm still doing example 8. Okay. So G++ -O EX8. And then I'm going to compile ex8.cpp, stack.cpp, and appdata.cpp. Okay. Oh, I forgot to change original. Original is not declared in this scope. Of course it's not, because I changed that. So that's right here in the assignment operator overload. And every place I've got original, I just need to put in right-hand side instead. This is where I regret naming this right-hand side instead of naming it RHS. So. So this is pulling data from the right-hand side of the assignment operator, and it's passing it or copying it into the left-hand side of the assignment operator. And the left-hand side of the assignment operator is this, or referred to as this. So with that change, let's see if that compiles. Woohoo, it does, holy crap. And so that's an assignment operator overload. I completely forgot to I'm going to drop the share for a little bit. I completely forgot to check the time when I started the recording. And so I have no idea how long I've been going on the recording. Oh, wait a second. Yes, I do. Because remember, I showed you my wristwatch right at the start, and I said it was 10:37. So I'm only half an hour into the doing this lecture. So now I'm going to drop the share and I'm going to pull up the PowerPoint slides again. Okay. So we managed to get all of this correct. That is the operator, the assignment operator overload. And so the next thing I'm going to work on is the stream insertion operator overload. And I almost never get these right. I'm looking at a book right now that shows me exactly what the syntax is, and I'm still convinced I'm not going to get this right. okay? So the stream insertion operator overload, these things are weird. And so we're gonna write some more code and we're gonna see if we can get this to work. So bring up my window again. I'm gonna be, again, this will be all done in app data. And I'm gonna start in appdata.h. And I need to include, so this is pound include. And I need, let me see, I wanna make sure that I'm getting the right include here. It claims all I need is IO stream, but I seem to remember that I needed more than IO stream. Well, I'm just gonna pay attention, you know, I'm gonna follow the book that I'm using, which is Nijhoff's book called ADTs, Data Structures and Problem Solving. So now what I need to do is to write this prototype for the stream insertion operator overload. I want to make sure I get this right. So down here, so this goes in public in sensor. I'm going to put it right after the operator overload for the equal sign. Some people by convention put all of these operator overloads down at the bottom. I don't. So here we go. This one, remember we have chaining on these as well. Remember we can do this. So that means that the stream has to get chained through these operators. So that means we're going to need a return value on this operator overload. And that return value is an O stream, an output stream, okay? And it's not going to be the stream itself, it's going to be a reference to the stream. And then just like the assignment operator, we use the keyword operator. And then we use the stream insertion operator. It's going to have a right-hand side, just like we did with the assignment operator. And so that's O stream reference out, okay? So there's a stream that's being passed along, but we also have a second parameter here, and that second parameter is the sensor class or a sensor object. And so that sensor object is going to be a const sensor ref, and we can call this whatever we want. What am I going to call it? This is a debate. I'm going to make it simple because I really hate typing out like right-hand side in the last one. I really hated typing that out. And so I'm just going to call this OBJ, okay? And that's it. So that's, again, we have to pass the O stream along when we're done with the stream insertion operation. The stream insertion operator on the right-hand side needs to have the stream so it knows where it's going, but it also needs to know the thing that it's printing out, okay? Now, this is absolutely going to take the place of the print function. In fact, we can get rid of this print function because it's now obsolete. So I'm going to delete the print function. And so that data member or that functional member no longer exists. There's no need for it. And then I am going to go back into the CPP file, and I'm going to go down and find that that print function. So right here is the print function. How many lines is this? Okay. So I'm just going to delete that print function out of here, and I'm going to go up up here to right after the assignment operator, and I'm going to paste it back in. Okay. And so I'm going to alter this print function to be my operator overload. So I've got to follow that same pattern for the operator overloads. So this is a const OStream. Okay. So let me make sure I'm getting this right. Oh, actually, we don't even need the const. I forgot about that. OStream, okay. Ampersand, operator, let's get rid of the rest of this stuff. Okay. And now inside of that is, let me make sure here, is an OStream reference that we're calling out. And then a const sensor reference called OBJ. Okay. So that's exactly how I wrote that in the specification. And it's bothering me right now because I feel like that should be there, the sensor. This is inside of the object for the sensor, but these stream insertion operators and stream extraction operators are kind of weird. And I said that in the PowerPoint slides, and I'm saying it again. The way they work, I remember at one point in one version of the C++ language, you needed to use the friend keyword and declare yourself to be a friend of the stream operator, whether it was insertion or extraction. So with that all said, really all I need to do is change these C outs to outs. And then we need to return out. Now the nice thing about these stream insertion and stream extraction operator overloads is that they'll work for C out and C in, but they'll also work for files. So if streams and off streams, that is input file streams and output file streams. And so this is a really powerful idea, this overloading of these operators. Now that should be everything I need in here. Let's see if it compiles. And I have my doubts here because like I said, every time I do one of these, I have a problem with them. So, oh yeah. my application standard output operator must take exactly one argument. That's not what I'm reading here. Oh, well, first things first, I see the ex8.cpp as a problem because I had print in there. Okay. So I just changed that so it no longer uses the print function, but it just uses the operator overload that we just did. I don't think that's going to change much because, yeah, there we go. You can't let yourself get freaked out by these long strings of errors coming out. No match for operators. So I'm reading right here. No match for operators, stream insertion operand types. And so it's complaining here about that overload. So I'm going to look in our textbook now, because the textbook I'm currently working out of, its code did not work, which is the first time Nyhoff has let me down, basically. And it could be that this is a recent change in the C++ language. The copy of Nyhoff that I have is about 10 years old. So operator overloading. Overloading the insertion operator. So pages 652 through 660 in our textbook. So 652 through 660. Overloading. Huh. Interesting. Okay. So OStream operator, stream insertion, const money amount, return outstream, class money. Ah, aha. Maybe. I might have. So in here, remember I said something about the friend operator or the friend keyword? What I'm seeing in our textbook, and this might be a change since Nyhoff, is that you have to friend these operators. And so I'm going to friend it right there. This basically says, hey, I'm a friend of the stream insertion operator, and you should allow me to write code and do things with that. So let's see if that, ooh, wow, that dropped the amount here pretty substantially. And now we've still got that data.print in the stack.cpp. So if I go to stack.cpp and I just search for print, okay, in print stack, we used that. Now I can just use cout. And I don't have to use that member function print anymore. So I just see out the data. And let's recompile and see what we've got next. ID was not declared in this scope, so that's in app data CPP. So VI. Oh, I know what that is. Remember, there are two parameters on the OStream operator. I have to refer to things using OBJ. I can't just use ID here. So this is actually OBJ. Let's see, OBJ dot ID, OBJ dot lat, OBJ dot lon, and then OBJ dot readings. Let's see if this runs now. Oh, there we go. Sensor ID is 42. The sensor's latitude is negative 23.02 degrees. Let's see, longitude is negative 86.79. What's the value for the next reading? 12, 23, 34, 45, 56. What's the sensor ID? 2525. What's the sensor's latitude? Let's make that 47.6 degrees north. Longitude of negative 87.45. What are the readings? That's going to be 1, 2, 3, 4, 5. And then sensor ID 2112. That sensor's latitude is going to be 42.16 or 15 degrees north. Longitude of negative, let's do positive, what the hell. Let's say 5.34 degrees east. Readings of 98765. Wow. So there's the stack contents right there. And then the while loop that pops and prints them all out. And so our operator overloads are working, especially the stream insertion operator. We know that's working because we see all of that stuff come out. Both PrintStack and EX8 use that operator overload now. And I am just about 2 minutes over on time. So that about concludes it for today. Welcome to we've come to the end of yet another day of Smith in his basement lecturing on 121. Check those midterm grades tomorrow. Like I said, I'm getting the grading done. Tomorrow I should have a couple of more programs to enter in, and I've currently got one that I haven't put into Moodle yet as well. And so hopefully those will get in. Thursdays are a lot better for me because obviously I'm doing this Wednesday night, and so I can spend my entire day tomorrow trying to get caught up on some grading. I did get caught up on my other courses gradings, and I've got the midterm grades posted in those. I did those over the past week. And so now it's just getting this class taken care of. So, and have a good weekend. Stay engaged, stay connected to your family and friends. We will get through this. I just want to say that be aware the lag time on this particular virus. We just went into lockdown this week, which means it's approximately 16 to 24 days from now. So probably on average 3 weeks from now before we start to see the flattening of the curve, to see the results of what the governor just did. The lag time on this virus is really long. 14 days approximately before symptoms show up, and then another 10 to 14 days until the virus resolves either in recovery or death. And so we really aren't going to see us flatten that curve for about 3 weeks. And so that puts us out right now to approximately the 14th of April, the middle of April. So don't let it get you down. You know, my goal was to make it to the end of March. For myself, that's when I went into self-isolation. So that's going to be about my 2 week point. And then after the first week of April is going to be about my 3 week point for self-isolation. And I'm hoping that I don't develop symptoms. And so that is the end of lecture 8. Take care. Goodbye.